Okay, good morning everyone. So I'll be discussing to you the one methods of topologizing sets. So technically, if we are given sets, we are about to convert it into a topology. There are two methods actually. So I'll be discussing to you the first theorem, which is the first method of converting sets into topology. So here. So this is our goal, to create topologies in sets. So that means my goal is to cover the next reporter for the second method. So here's the theorem. That's the first method. So you're given a set, sigma, which contains a sub alpha, coming from where your alpha is coming from a different A set. So, and that sigma is a subset of the power set of X. So that means it's one of the collections of subsets coming from X. So there exists a unique smallest topology, the T of the sigma, with sigma subset of tau of sigma, where this can be described as follows. There are descriptions. Number one, it consists of the empty set, the X itself, the finite intersections of all A sub alpha, and all the arbitrary unions of these finite intersections. So, let's differentiate these. You have the finite intersection of A sub alpha. You also have the union of those finite intersections. So, number two, that sigma is called the sub-basis for the topology na tau of sigma. So the tau of sigma is said to be generated by sigma. So technically, it's just a definition. So our main focus here is to show this. The rest are just definitions of tau of sigma. And number three, given a topology tau, a family here of sigma, which is a subset of tau, is called the sub-basis for tau. Whenever you have the equality, tau and the tau of sigma. Okay. So remember, we are only going to show I and the rest will follow. Okay. So, Anissa, I have a set here. Ang pasabot daw niya, if you look this, you have the sigma here. There exists a smallest tau of sigma na naapa ko na yung mas muda ko niya, pero this is the smallest actually. Like, wala. With comparisons to those na nag-contain si sigma. Nakuha niyo ako. You have another, ano ba? Ano na lang, ako na siya i-delete ha. You have the sigma here. So there are other sets na nag-contain niya. So you have to find the smallest na naapan yun siya. Nakuha? Okay. So technically, if we are just not talking about the smallest, then we're getting all those our sets. So this is unique. The unique term here is we're getting the smallest. Okay? So it's actually in the task of the next reporter, but I'll be showing to you lang by slides. Hindi na siya explain. Okay? Next. These are examples of getting the method of first. Oh, yeah.
What do you mean by the smallest? Meaning sa first condition, the smallest siya man actually empty X of all finite, or that is the method?
Yes, definitely. So, kani siya? Kani siya, pag makuha kag pinaka-smallest pag-yun, naan siya daan sulod. Makuha kag the smallest set na gisulod na daan sa sigma. Technically, you can get all the sets nga na contain sigma, but you have to select the smallest. So,
I-proof ba ito ni Maya? I-proof ba na mo?
Yes. Okay. So, here are also the remarks, but I'm not going to discuss that one because that will be for the next reporter. So, first is, before we're going to show that, balikan sa mga itong preliminary. Na siya previously, na-discuss na ni. Like, if you're given a set, can be any family of topologies in X, then the intersection is also a topology the next. But the union need not be a topology.
Yes.
Okay. So, for the proof, so let's start with, of course, you have the sigma, which is an element of X. And, di ba may the definition says that T of X is the smallest. So, our target is, kay smallest man, murag na na, it's yung na nato na, you will get the intersection.
No, sigma.
Ha?
Ang smallest kanina, sigma.
Yes. Okay, so, muna siya, the tau of sigma, the intersections of all A sub alpha. And your A sub alpha, of course, is a topology. Okay. So, since sigma, nga, gikan man, di ba, element man siya ni, subset man siya or element man siya ni power set of X, kay sigma is one of the subsets of X. So, it says here that P of X is one of the, I think na yung mali, na ito yung technical error. Do you have book? Wait lang. Na ito yung technical error. Oh yes, tama. Di ba si sigma may element siya ni power set of X? So, which means the power set of X is one of that. Is an alpha. Yes.
Sorry.
Oh.
Kanang pwede balik sa theorem kay pwede mo ma-illustrate on sa ng tau sigma A alpha ano na drawing.
Kuan, sige, right ha.
Kana.
Okay. You have the sigma na kay A sub alpha. Now the index, which is the alpha, is coming from a different set A. Remember, dilahin ako sa notation. Okay. But take note, those are representations when actually coming from the power set of X. That is why conditional collection also is a subset of the power set of X. Okay. So, okay ra? Continue ko. Sige, let's go to the proof. Okay na.
Ang intersection ba? Sigma is from alpha and A sub alpha.
Yes.
Ang intersection of A sub alpha.
A sub alpha, where your sigma is one of the katong topology.
Okay.
Kaya si A sub alpha naman, yes.
Ang condition sa mong theorem guys, si A sub alpha is just a subset of X. Yeah.
Ang A sub alpha,
Is this a subset of power set?
Power
Condition
set.
topology.
ang saman.
Ang A sub alpha mo.
Ang A sub alpha is a topology na. So it's coming from the X. So katong sigma na contain atong mga A sub alpha, which are collections, are subset of the power set of X.
Kasi sa theorem kay subset ng sa power of X. Hindi man siya, kung kasi nga topology siya.
Ayan, muna to i-show. Di ba ang sigma to i-show?
Si A alpha.
I mean, T of sigma. Ang A
A
of
alpha ba na
alpha,
topology kasi alpha
Topology siya.
or a curve ba na?
Diba sa imo ba mong i-show na topology?
Hmm.
Ay na, as per
Tara.
preliminary.
Preliminary. Naa siya sa 1.4 ata.
Pero ay,
Hindi nga sa case siguro, pero
Eh,
sa
pero-
theorem.
That's arbitrary. Symbol naman.
pero ang condition there is ang imong P alpha is a topology. Pero sa imong theorem kay imong A alpha is not a topology. Isa set lang siya. So, ang subset ni X.
Di man. You have this collection, the sub alpha, the any family of topologies in X.
So, topology siya.
So the intersection is also a topology. So kato siya,
Dili man siya topology
Wala ka nag-assume dito nga topology ang family. Ang sunod sa imong family.
ano ta sa murag
Si
gi-assume
X topo. Topo ba si X dar?
Si X.
Si X kay just arbitrary set lang. The first source for when given from the leads to a unique topology could be then we can
isang alpha with
So, inyong i-verify ng isang alpha topology bus.
Yes, sir.
So,
well, di, siya previous actually, naka-resolve, naka-resolve ko ang pilapit. Nakita na ko na ko siya.
Sige, sure. Na-siya yung default actually.
Even any family or
An element of X, and you let T of sigma be the intersection of all topologies. Na si A sub alpha topology na siya na I assume that that is a topology that contains siya ni sigma.
So,
Yes. Ako sa nawala ako, sorry. Pasensya. So, ako ipalay na ha. So, since daw si sigma is also an element of the power set of X, so si power set of X daw, usap po ni siya ani. Kaya di ba, this is an element of A sub alpha, and this is an element of this, which implies that ani siya is one of these A sub alphas. And so, such topologies exist by preliminary. And since T of sigma is equal to the intersection of A sub alpha, so again by preliminary, that is a topology. So let's assume that the preliminary is proved already. Now, given topologies A sub, okay, let's assume an arbitrary topology is A sub alpha and B sub beta. So let's show that if we have this equality, note that kani siya T of sigma equals A, and you have T of sigma bar equals B of beta bar. Okay. Now, since dali naman, it's very obvious. Equality, transitivity, these are equal, therefore this is unique. Wow. Transitivity lang. Let's assume these are equal, then they're unique. Okay, moreover, it follows that T of sigma is the smallest topology containing E. Because, again, ito yung question, Ron, na it's the intersection. It's our instinct. If we show the smallest set, we'll get the intersection. Yes. Okay, next we will verify the description of the members of T of sigma. Okay, let's go back to the theorem again. Only ang description, di ba?
so katong first thing mo gibuhat, mo gibakita na
The existence of topology. Then here, actually prove this is true. The rest are definitions this will follow.
so proving mo na sa existence and the uniqueness.
Yes.
And such is smallest ability.
So, dilita sa katungkuan. Okay. Remember that sigma, di ba subset naman to siya lahat? By the definition, tau of sigma. So it follows from the definition of topology. So, of course, MT and X is an element of tau of sigma. Since, of course, tau of sigma is a topology. So it follows na sigma, si MT ko si X, na ako dito. Nasatisfy na. And by the definition, tau of sigma contains all finite intersections of A sub alpha. Ako nila, di ba? The intersection. Tau of sigma. Ano siya? This is
sigma from
ano siya? So, and also by equality of sets, tau of sigma, ako gi parenthesis siya kay ako siya gitawag equality of sets, but it's not technically wala man siya gisulti sa libro sa Topo at equality, but for our common sense it's equality. So tau of sigma, it consists of arbitrary unions of these finite intersections. Penny, ang tawag sigma daw, di ba mo siya ang intersection. Since these are finite intersections, if we pick finite numbers of topologies na A sub alphas, ato siyang i-intersect, dahil magpapalit mo another group of intersections of A sub alphas, then if we get the union, it's just the same as this. Because they're all collections of topologies naman. So that's why mo siya ang ipaglabas. And conversely, of course, all these properties do satisfy the definition of topology. Like, di ba sa to? Anong conversely niya, ano nakabalik ta sa balik ta sa presentation, sa definition. Okay, here. Definition of topology, it contains the empty, it contains the X, and it contains the finite intersection, and as well as the union. The union is just a complement of the intersection naman. Then, isulti na ako direct. So, that's why the converse is also question.
Kasi ito yung pag-divide ng all finite intersection of A alpha.
All finite intersections of A alpha. So, tanang mga finite count lang siya. Ano siya? So, kung i-intersect mo na siya, that is a finite intersection ka na, sa kanina ako mag-explain na. Mura mo siya obvious nga so i-explain. Like, di ba na kay set? Then na kay mga A sub alphas, mga finite lang sila. Like na itong arbitrary union kay namatay anak. Dili kay you start from I from 1 to n lang. So there are n number of A sub alphas in a given set.
So hindi siya magbalik. Either mag-intersect of 1, of 2 elements, 3 elements, 4 elements. Tanan din sila kung ng intersect.
Actually, tanan din siya, di mo i-intersect, di ba? Kaya kung mo identify ang topology, let's say kani, di ba, yung mo siya i-identify kung naaba niya ang intersection ani, naaba sa topology, intersect ako ni mga isa, ana-ana. So, isa-isa mo lang sila tanan. Yes. But, katong dito po sa union, di mo lang mag-gusto lang na-classify. Kaya wag i-pares lang kapag-pares, kanila i-pares, the union is still the same. Ana. Question.
Kung may pangutana,
Ang example ano kay JP naman no?
Yes. Kanang ani magud pagbuhat na ko ani, I haven't consulted JP. So kailangan maghatag ng examples, examples. Ang ending ng utang ng JP siya example daw ya sa line kay di ba?
Di man siya pala
1% na si JP. Tawag na.
Yes.
so, mulat na sa ka.
So ako lang wala na ako siya i-delete. Ako lang siya i-show para ready na ako para ni JP. Wala na? Sige, balik ko na kung kapit dito.
Okay, so thank you very much, Mark. And unless you have some more questions, makita lang ni Mark sa iyang report na, what was that, Mark?
Kato, one of topologizing sets on existence sa smallest topology na nag-contain ng sigma. So, yes, so one method di siya. Na pa yung next
So
method.
yan ang pakita na nag-exist yun, then such existence is unique, so is just the smallest.
The smallest topology. That's all.
It's not a good. So di yun maipti no.
Sunod naman na sa
Di man siguro tatanan pero tas na